The next example determines the length of the curve. Check out how this is done here in engineering surveys. A forward tangent of -4% and backward tangent of +7% meet at PVI with elevation of 230 meters and station 6 plus 300. They are connected by an unsymmetrical curve. The curve passes through point A of elevation 227.5 and station 6 plus 270. Also given is the length of the first curve at 60 meters. The first task is to find the length of the second curve, then to locate the station of the highest point, including its elevation. Let's visualize how the curve looks like with all the included details. The back tangent is +7%, and the forward tangent is -4%. They meet at PVI with elevation of 230 meters and station 6 plus 300. From PVC, the length of the curve is also provided at 60 meters. Another point A is also given at elevation 227.57 and station 6 plus 270. Starting with the length of the curve, what we got is the function for L1 as equal to 2h times L2 upon the length of the second curve times the difference of the grades minus 2h. There are a number of unknown parameters. Nevertheless, place the given values to clearly identify what are needed. 60 is then equal to 2h L2 all over L2 times 0.07 minus -0.04, then subtract 2h. This is then simplified as 60 is equal to 2h L2 upon 0.11 L2 minus 2h. So there are h and L2 yet to be secured. To look for h, we use the details from point 1 with the vertical offsets function. X squared is to y as L1 squared is to h. Since the whole length of the curve 1 is 60, then station PVI and station A has a gap of 30 meters, we can also deduce that the gap between PVC and point A is also 30 meters. The next parameter to look for is y, and this needs PVI. But what is y? Looking at station 6 plus 270, y is the distance between the tangent and the curve in this alignment. So solve for the tangent height first using gradient. That's 0.07 of 30 meters, giving 2.1 meters. Thus, from the elevation of PVI, which is 230, subtract the height of 2.1 meters to look for the elevation of the tangent, which is then computed as 227.9 meters. Compare this with the elevation of point A, which is 227.57. Thus, the gap between the tangent and the curve is y of 0.33 meters. With y already known, get back to the proportionality and fill in the parameters. 30 squared is to 0.33, as 60 squared is to h. Cross multiply and simplify to have h of 1.32 meters. With the value of h already identified, get back to the function we simplified earlier. Then plug h of 1.32 meters. That would have 60 is equal to twice of L2 times 1.32 all upon 0.11 L2 minus 2 times 1.32. Cross multiply and have 6.6 L2 minus 158.4 as equal to 2.64 L2. The length of the second curve is then solved as 40 meters. The next question is the stationing of the highest point of the curve. First, identify where the highest point lies. This is comparing half of L1G1 with H. Place the values, making 60 times 0.07 over 2 as 2.1, and this is larger than H, which is 1.32. This means that the highest point lies on the second curve, so we are to use S2 in finding for the station of the highest point. S2 is equal to G2 with the square of L2 upon 2H. From the figures, S2 is then 0.04 times the square of 40 all over twice of 1.32, giving S2 as 24.24 meters. 24.24 is the distance from the highest point to PVT. And since what we know is the elevation of PVI, take the length from that station. The distance is then L2 minus S2, which is 40 less 24.24, giving 15.76 meters. So from the PVI station of 6 plus 300, add the distance of 15.76 meters, and get the station of the highest point as 6 plus 315.76. For the elevation of the highest point, we tackle this from PVI. The difference in height from the PVI to the tangent across the highest point is solved as 0.04 multiplied by 15.76, giving height of 0.6304. Next is to determine y using the vertical offsets function. And getting the square of 24.24 is to y as 40 squared is to 1.32. Y is then 0.48 meters. With these two vertical distances figured out, we start from the elevation of PVI at 230 meters. Subtract the height of 0.6304 to take the tangent elevation of 229.3696. Then again, take out y of 0.48 to provide the elevation of the highest point as 228.8896 meters.